Live from New York, it's Asking Engineers.
Hey everybody, and welcome to a special early extra video edition of Asking Engineers. Today we have two engineers, me, I'm an electrical engineer, and we also have Tony DeCola in the flesh with a really awesome Joy Division kitten shirt.
Right.
And welcome to our Soho factory. We're here in Manhattan. You've traveled all the way from Adafruit Northwest.
The Great Northwest.
The Great Northwest. It's rainy here too, so I hope it's just like
I brought the weather over. So
thank you. We have a pause today for the wearable show. Usually we'd have the Becky Stern wearable show, and never one to stop streaming. Always be streaming is what I say.
Yep.
ABS. We're going to we're going to do engineering. But we're also going to talk a little bit about wearables. You ready?
Totally. Yeah. Talk about some fun products.
We're going to talk about some fun stuff. So, you're a creative engineer at Adafruit, and so just quickly, what do you do here?
Yeah. So
what do you do here?
Well, so there are all kinds of projects and things that we do. So we'll have all kinds of new products and things. Like we're going to look at an interesting product here, but to use that product, you need to know, okay, what code can I use with this? What libraries work with this? And so I work on building those libraries, demoing them, like showing projects with them. And you can actually go to our YouTube channel and see a lot of different projects and things that I've done. Like, the last project was some Christmas lights that you can control that show off the feather boards. And so it's interesting ways of using some of these little tiny boards and making, light displays that you can control with your phone, like Bluetooth Low Energy, that type of stuff. So basically I'm just using all the products and things that we have and showing people what you can do with them. And helping to build like some of the libraries and things too for them.
And you're like quadlingual because you write code in Python,
oh, yeah, exactly.
C++, Quick Basic. You'll do anything.
Right. Hopefully I have like an old TI-99. We can get that thing set up, connect that to an Arduino.
So today what we're going to be talking about is a future product that I'm roping you in on against your will. No, I'm sure you're into it. We're going to be talking about the new Circuit Playground board that I'm working on, codenamed Circuit Playground. Hey Phil, can we go to the overhead? Thank you. And this is it, and I've been doing a lot of desk of Ladyada. This is when I stream from home while I've been doing the engineering for Rev A. You can tell it's Rev A because there's like a little green wire over here because it turns out that the pinout wasn't what I thought it was. And this is a little board that looks a lot like Flora for people who've done wearable projects with the Adafruit Flora. And I'll just do a really quick tour of what you've got here. So it's a round circuit board, and it's got a micro USB connector here for power and programming. You can also power it from this JST connector, so you can use like a AAA battery pack and stuff to make it portable. So you can unplug this and power it from down there to make it portable. It's got an Atmega 32U4 processor, which is the same as the Flora. It's an Arduino compatible processor that does USB as well. It's got two buttons, left and right, little tactile switch buttons. There's a little reset button here for if you want to, if you press it, it goes into the bootloader. In case like something goes wrong while programming, you can always reset it. There's a piezo buzzer, a magnetic buzzer. It's actually a little speaker, and it's very small. It's going to be even smaller. This one's a little big. I'm going to pick a smaller one. And there's a sound sensor, a MEMS microphone with a little analog circuitry that amplifies it so that it can detect speech, noises, sounds and stuff. There's also a little slide switch here. If I slide to the right, it'll start making a noise.
Awesome. Yeah, totally.
I put the piezo on the slide switch detector because I was like, it's a little annoying.
Yeah, right. You can shut it off sometimes.
And this is just a demo program. It has 10 NeoPixel RGB LEDs, so 10 LEDs that can be RGB. And then on the outside, there's these pads that are alligator or sew friendly, so you can sew to them, or you can grab an alligator and clip an alligator clip onto them, so that's kind of handy. And there's a bunch of power and ground pins and 8 GPIO I/O pins. So there's some of them are special. So there's an I2C clock and data, UR clock, RX and TX. They can also be used as everyday GPIO pins, and then there's 4 pins over here that can also do analog as well as digital. And these pins also have resistors pulled up to another pin so that they can be used as capacitive touch sensors. So when you touch the pad or touch something connected to the alligator clip, it can detect it And I
Right,
think
like a switch almost in some ways, but capacitive.
yeah, so it's like a touch. It's a touch sensor, and then there's also it's very small, but there's a light sensor over here, and a temperature sensor over here. So it can actually do very precision temperature. The light sensor just kind of tells you is it bright or not. So that's kind of the overview of the board. It's designed to be an all-in-one board. Like you can basically plug it in, start programming in Arduino or CodeBender.
And I like, there's no soldering, so you've got all the components on the board, which is one really nice thing. Like if this is a classroom that might want to use this, you're not going in and say, okay, step one, pull out the soldering iron, learn how to solder.
Or step one, get the voltage regulator going.
Exactly right. So this is, you've got the board, you plug it in, you start writing code for it, and you've got all the components on there ready to start using.
Yeah, and the reason we designed this is because and you've been talking to code.org, which is a Hour of Code nonprofit, and they're interested in getting more people interested in programming. But just from the projects that we've done with schools and even companies doing hackathons, we keep getting the same question, which is like, it used to be like 10 years ago, you want to learn electronics. It basically was like build your own like crystal radio kit.
It's like a rite of passage.
Yeah, yeah.
How difficult can it be? I got through it. I figured out, I know how to make this radio from scratch.
You can make a radio from scratch. Just like get your germanium diode, and then it was, okay, you can program a microcontroller, and you would actually have to like get a UV eraser, and then actually it was like Arduino, and you still have to maybe solder a couple items, and eventually got to. We had solder kits, and we would sell them to groups that wanted to do workshops for teaching electronics, but actually they just didn't have soldering irons, and they maybe couldn't afford them. So then we started coming up with like, here's solder-free projects like the ArtX, where you can do electronics without any soldering, just breadboarding. But nowadays, we're even getting people who say, we don't even have time for that. We basically have to do a full workshop in 45 minutes, and there can't be any wiring, any soldering, any significant code learning. They want to use Scratch or Blockly. They want to, or Minecraft. They want to basically get it going as quickly as possible, and they also want it to be like $25,
right.
Per person.
Everything.
Yeah. And so we're like, okay, we don't have anything. So this is what this board is. This is explaining where this came from.
Goals of,
the goal of this was to design something that could be used by students, workshops, where you get it and you're basically. You have example code and you plug it in. It works with any operating system, minimal drivers, installation, if any, and you're just ready to rock.
And the other nice thing too is that you can use this for like wearable. I mean, like you were saying, it's similar to the floorboard. So you could build like a jacket or something that you put this on, which like neat little demos of.
Yeah, what I like is that it's designed to be portable. So you can plug it in to program it and debug it, but then when you're done. You can run off of, we have these AAA battery packs. Mm-hmm. So you don't even need a LiPoly battery because it's shipping LiPoly batteries or giving them to young students is kind of a little bit of a risky proposition. They might put them through the wash by accident, which could be a bad scene.
Exactly.
Just get battery acid or whatever. So having a removable battery pack, and we have them in it. So we use them for floor projects all the time. They're a little big, but AAAs are very safe, easy to find. You're not going to swallow them like coin cells.
Yeah.
That's another thing. We can't use coin cells because they're really dangerous because young kids swallow them.
Yeah. Totally.
It's a problem. So that's why I don't have. Also, they're also very difficult to ship.
Right.
Just explaining like design decisions. So now that we've spent 10 minutes introducing it.
Answer questions, or do you want to?
We can answer a couple questions, but also, what the goal of this was to trap you here in this cage and force you to think of projects. What are, I want to come up with maybe like 10 to 20 different activities that we can do with this board. It's not, we're not going to be able to do everything. But what can we do?
Yeah, totally. Well, I think it's interesting because you can kind of explore the interactivity with the computer aspect of it. So one really neat.
I got a piece of paper too, so I'm going to document
this. So one cool thing when I was at Maker Faire New York, I saw a gentleman who was a teacher. He teaches an 8th grade class. And he had a really cool thing. He was using the Makey, which is like a little capacitive touch board where you can hook up wires or hook up anything to it. Excuse me. And you can basically turn it into like a keyboard. So you touch like a banana or you touch a fruit piece, and that'll generate a key press and have a little fruit organ, which is kind of a cool demo. But he was using it in a setting where he was teaching geography, I think it was, and he would have his students build little pinball tables, like make a game, like something fun. that teach history and geography and things like that. And he was hooking up the makey to different parts of the pinball table, so that you might have like a bumper that you put aluminum foil around, so it has to be conductive. And then as the metal ball kind of rolls around and hits the bumper, the capacitive touch sensor can detect that. And then it can send it as a key press to your keyboard on your computer. So you might have like a scratch application running, something simple that a kid might be able to program. And real easy way, you're just using your keyboard. Like, you don't have to understand, okay, how do I communicate over the serial device, and like, what's this complex protocol? Like, just make the device act like a keyboard and send a key press. And he could do all kinds of things with that. So like, make sound effects, like whatever the kids could imagine. They could turn, this physical game into something that interacts with the computer and maybe like keeps score. So I think that's a really cool demo here that you can do is, different interactivity with your computer.
Capacitive, so it does have 8 capacitive touch sensors, capacitive touch, 8 sensors. Oh, you know what? I keep forgetting about the one last thing that's on the board. There's also an accelerometer, a triple axis accelerometer. It's really small. That's why I keep forgetting it. And then you can barely see it. But there's a LIS 3DH, which is a triple axis accelerometer. It's a really good quality one. And it also has free fall detection and tap and double tap detection.
Right.
So you can tap it as another input. So there's buttons and a switch, but you can also tap it from the side. It won't really detect which side was tapped, but it will detect that it was tapped or double tapped. Okay.
And if people aren't sure too, the accelerometer kind of detects the forces of gravity, so you can do some basic orientation.
So if you move it, or if you drop it, or you tilt it, it can do tilt detection.
Exactly.
That's kind of nice about accelerometers. You can do tilting. Okay, so it's a capacitive touch, 8 sensors to
as
keyboard.
A keyboard input, or even like a mouse, like an easy way to control things on your computer. So that you don't have to build these protocols and figure things out yourself.
Okay, so that's at number 1. So that's a good one, because we do have. I did try out the CapSense library, and it works very well. It has 1 mega ohm pull-up resistors, so it can detect. It won't. It doesn't do proximity sensing unless you have a huge piece of aluminum foil. But you could try it, and then you would just clip an alligator clip from here to your banana. I don't have a banana with me, so you guys have to.
Well, you can clip it to yourself.
Invisible banana for scale. Okay, so so then maybe you can do like fruit drums or stuff like that.
Right. And you've also got the speaker on board too, so you can do things like tone generation. You could have like a little basic synthesizer.
Okay, so wait, hold on. This is idea number 2. See, this is why I've trapped Tony in this crystal ball, because ideas just come out of you. Okay, so cap touch, and then this little beeper. It can do tones. I mean, that's just so you know, that's ranging from 500 hertz to 10 kilohertz.
I mean, that would have been top of the line, amazing synthesizer in like 1960.
So capacitive Casio tone.
Yep.
Capacitive Casio, and then you have a slide switch, so you can do octave, and then you have 2 buttons, so maybe you could have different activation.
Like volume level, even if you want to.
That's true. You could do volume up and down. Although volume is a little tough because it's a buzzer, and even though
kind of on or off.
I'll actually tell you a secret. Shh, don't tell the audience. So it's it's a magnetic buzzer. So it's actually like a speaker, and it goes through a transistor. And even though it's on a digital pin, which normally you would just clock up and down at like kilohertz, it's actually on a very special pin on the 3340 called OC4A, which is the high-speed PWM output, which can do like 4 megahertz PWM.
Okay.
So you can do such high-speed PWM that I think we might be able to.
Like you could turn it into a speaker almost.
You could actually do.
Audio.
I mean, the only thing is it's not a flat response.
Right.
You could hear some tones a little louder. It peaks a little bit at 4 kilohertz, but even though it's square wave by default, just by clocking the pin up and down, you in theory could do sine waves.
Right. Like kind of how a lot of high-end amplifiers these days work, like the Class D amplifier.
Yeah, it's kind of fake Class D. Like, by the way, I haven't actually tested it, and it
Phil B has a project, I think, with the high speed on the AT-Tiny 85, I want to say. So it should be pretty similar to that.
And we'll have to test it and then see if I have to add any like inductors or extra capacitance, because I basically just pushed it straight through an NPN to just give it amplification, because it's a 16 ohm speaker. So Cap Touch Casio tone, and then maybe switch for octave select.
Yep. Or even changing like the tone.
Octave or scale.
Yep.
And then buttons for volume. Okay, I'm writing this down. Okay, so it's 2 ideas. We're doing great. We're a tenth of the way there.
So the other neat thing on it too are the sensors. So you have like the temperature sensor, and you can do kind of basic displays, and you have all the pixels on there. So just something like let's turn the temperature value into light. So maybe like light up all the pixels, maybe animate them and change the colors, so go from like a blue to red gradient of colors based on the temperature value. So kind of like maybe a neat little ambient display of temperature data. You know, you can have it, maybe even like wear it and you're walking around like, what's temperature? Oh, you know, it's pinkish blue or so. That must be like 60 degrees.
So like RGB.
Yeah, visualizing sensor data is like a broad topic, but there are a lot of ways you can kind of play with that.
Yeah,
Something like this.
just so when you touch it, you know, it's like I don't know a better word for it, but they're called like the lovometers. You know what I mean? It's
Sure.
the old project where, you know, the warmer you are, it's like you're passionate,
Yep.
and, you know, cold fish. I mean, it doesn't mean anything. It's just like, how cold is your skin? Another idea that we could do is, this is one of the projects we did for the data logger, is it does have a little bit of EEPROM in it. So you can do data logging to the EEPROM and then read that back. So you could do a fridge meter.
Like, yeah, what was the lowest temperature we saw? What was the highest temperature?
Yeah, you just put it with the batteries,
Yeah.
you put it in, and also it can detect when the door's open and closed, because what's
Right.
interesting is you correlate when the door
Get a drop in
opens,
temperature.
the temperature drops, and like how much does it drop? So that could be like a
Yeah, it's
sciencey
kinda
project.
interesting. Right.
So fridge meter, fridge-o-meter, so light and temperature to EEPROM. Okay.
The other thing too, excuse me, the accelerometer. So I think there are a lot of neat things you can do with that as far as, and coming back to like the input for computers. So I think it would be neat to do a demo of like, make the tilting the board control your mouse. So like move the board up, down, left, right,
Okay.
and turn that into mouse movement. And you could use that to like control a game. So like have a game, like a scratch Pong game, for example.
Yeah,
And say, okay,
or like
now
a, you know, like you know those. I do, like, nobody's gonna. You and I will remember this, but like nobody young will remember this. Those little games where you had the little ball, and you'd have to tilt
yeah, like
to
a
get the.
Minotaur maze or
Marble
something like
Madness.
that. Yeah.
It's not Marble. No, Marble Madness was the game. I'm talking about the little,
A labyrinth, I think.
the
is
little
what it is.
labyrinth
Yeah.
games.
Where you spin it, and then that's what the real way to solve it. There's multiple balls. I just read it. That's the trick. You spin it. All that time, you're.
Top secret game tips.
Top secret analog $5 game. Yeah, you know, like a little labyrinth. So
Right.
so
You
accelerometer
could
to
make-
mouse.
Yeah, well, and you could actually make a scratch program that's like looking at, you know, the location of the mouse and saying, okay, now let's tilt this virtual
Touch a
labyrinth
mouse.
table.
And then maybe like, you know, labyrinth. Oh
Yep.
man, I don't know how to spell labyrinth game. Yeah, we did do a project with a really, really long time ago with the Teensy when it first came out. We stuck it in a Super Nintendo and used that, you know, so you could have the Nintendo controller. So you use the controller, but then it also tilted.
You had the accelerometer connected to it. Oh, that's pretty
So
cool.
it was the mouse, and then you'd have the button, so you could kind of tilt. So it was like to
Yep.
tilt to aim type games. But yeah, so accelerometer to mouse for labyrinth or other.
Right, any kind
video.
of game or something like that.
Okay.
Because it's neat. It lets you explore kind of the interactivity of, you know, like you could teach with programming by just building a game and using mouse and keyboard, but it's more interesting when you've got like a physical thing you can touch. You know, it makes it more kind of engaging.
And you also have left and right buttons, so you can tilt,
That's
and
true,
then
right.
you still have the buttons, so you
Well,
don't have to worry
and my
about
thought
that.
too is that if you do have mouse control, you probably want to be careful because like if you drop the board, you don't want your mouse to go flying all over the screen. So maybe have a button that like turns on the mouse mode and maybe turns it off. So like gives you a second to pick up the board, get into a spot that you want.
Oh yeah, because otherwise, well, yeah. I mean, if you don't have the buttons held down, maybe it's not so bad because it's not
Right.
like it's going to pick it up and like throw away your hard drive or
Right.
something. There's always a fear when I'm testing touchscreens. I'm like, I accidentally drag
Right.
all files to trash. You know.
Exactly, yeah.
Okay, so that's 5 ideas. I actually thought of another one. So, you know, we have the LEDs and buzzer and capacitive touch. You could make a basic Simon Says game where you touch.
Oh, right.
You know, you touch and then the LED. I mean, you wouldn't use all the
Pattern flash.
LEDs, but it has a buzzer, so it could, you know, it would basically be a duplicate of those Simon Says games.
Yep.
So, who made those? Was it like
Mattel. I would
Mattel?
say.
Mattel.
Yeah.
So a Simon Says with, you know, the computer's not required. It's just
Right.
the button. The piezo. I keep calling it piezo, but it's a buzzer.
And that's a good one
Buzzer.
too because that's a simple game that is
Tap
a little
touch.
bit easier to program than like, hey, I want to build a Tetris clone or something where you need to get a little more advanced as far as like building a game like that. You know, Simon Says you've just got a few different states that you can deal with and just memorize this pattern and play it back. So it's
Yeah.
a good, simple kind of learning project for it.
Another thing is, like, you know, because I was looking at other boards that are similar, like, you know, the Microbit is one of them, and, you know, there's another one, like, it was like a can't remember, but it was the code bug or something.
Well, there used to be the scratch board, I think, was also some of the
Yeah, those have a 5x5 LED matrix, but they don't have a lot of sensors. So, it's a trade-off. They have, the middle is just this 5x5 LED grid, which is actually not that expensive. Like LEDs are only a cent a piece. So, adding that isn't very expensive compared to RGB LEDs, but I want to make sure that I do, I put 10 NeoPixels on here, and they're kind of pricey. That adds,
Well,
10 cents each, a little bit more.
the space
per.
too. Like if you need a matrix of LEDs, you're going to need a bigger board for that. So that's
That's another thing. I was like, I guess I could have made a super small one, but I wanted to keep the accelerometer in the very center,
Right.
because that way you get the full
you
tilt.
can move it, you're not kind of off axis in some ways.
Okay.
Another project that is probably just a drop in, put the code on it and go, the Amplify project, where it's basically you've got the microphone, and so you listen to the audio frequencies, and you could just map the frequency value to lights. So say, okay,
Amplify, I think, is only just volume,
Right,
but
the
you could
volume.
do an FFT as well.
Exactly right, and so then you can get more advanced and say, let's run a little FFT library, because the 32U4,
You can do it.
There's a base, like you do like maybe a 512, byte array of FFT data.
No, we have
And,
one for the. We definitely have one for the 328,
Right,
and if the
there-
328 can do it, then the 324
Exactly.
can do it.
And so once you do the FFT on audio data, then you can look at the frequency content and say, okay, now I heard a high frequency tone or maybe a low frequency tone. I remember there's a neat little project I did with the Teensy early on, because the Teensy has a really fast ARM processor, and it actually has like
The Teensy 3.
Yeah, the Teensy
Yeah, the
3.
Teensy 3 can definitely do
Right,
FFT.
It's got like a DSP and all this stuff. But I did a neat little project where you can like whistle and detect the different tones. of
Oh,
things,
that's
like,
right. You did
unlock things.
Weren't you trying to detect your cat noise
yeah,
or something?
so I want to have a cat purr detecting collar. And so cats purr around like 20 hertz. And the problem is when you're trying to detect a signal that low, you've got a whole bunch of other noise. Like there's 60 hertz noise from power mains if you're connected, or just low frequency vibrations. So that project didn't really work well, but it did work well for detecting higher frequency stuff of voice and on audio. So like whistling a tone. So I had if you whistle a certain tune, it would kind of detect that and flash. And you can maybe lock or unlock something with that. But you could do something maybe not as complex as that, but looking at here's like a VU meter, or not a VU meter, but like a visualization of music to say, okay, what's the bass music? Maybe you light up some LEDs, a certain color for bass, some other LEDs for your treble. And your
Yeah, you
high
could have
range.
each one be a bin. I mean, it doesn't
Exactly.
do stereo, it only does mono, but you could have it be balanced, but each
Right.
one could be a bin, and then red is low and blue is high
Right.
frequency. I mean, I think we basically did that we did the Piccolo, that was a Phil B project.
Right.
Okay, so I have two, I'll put that down as two projects, the Amplify project
Right.
and
And
FFT to RGB. And actually, that reminded me of an easier project, which is a metronome, where you would either tap the accelerometer or tap a button, and then it would beep. It would basically keep track of what was the average time between those taps.
Yeah.
So it's pretty handy. People who do
Musicians
musicians
or
or DJing, they try to do
exactly.
beat matching, so they'll tap it, and then as long as it just continues whatever tapping that you did. So when you listen to a record and you tap out the beat, and then it'll just continue, and then you don't have to
Right.
keep track of it.
And that's also an interesting kind of programming problem too. Like, how do you detect the frequency of a signal like that? And so there's maybe interesting kind of learning you can do with that too.
Metronome. Yeah, I mean, it's not like the FFT, because you would actually be literally tapping it out, but it's an easier project. So metronome with tap tempo, basically. Okay.
Now another interesting thing I think too is, so this just has the AT32U4 processor on here, which is, it's good, but you can't run like JavaScript or Python or, these
No,
high-level
you can't.
languages. But what you can do is you can use something like the Firmata firmware in Arduino, which is basically a little firmware that you load onto the microcontroller, and it just has a certain protocol to say, okay, from my computer, if I send a certain command, I can read an input, or I can set an output, or maybe read a sensor value. So it gives you that interface to say,
I think the
okay, I
Scratch,
wanna-
the Pico board, that's what it does.
Right, exactly. And so, and they're
Yeah, let's put down Pico board.
right. And so just using that kind of Firmata, using that as an interface to higher level languages. So, I can't remember the name of it, but there's certain like JavaScript programming environments now that can hook up to those different things like Firmata. So, you don't have to teach.
Well, Max
kids-
MSP, I think, because Firmata is actually MIDI.
Oh, right. So you can even hook. Yeah,
So you hook it up.
exactly.
Basically, it goes right into
Just a MIDI
something
device.
like Max MSP or Pure Data, because it
Right.
it looks exactly like it, and so you could have it light up, or LEDs or audio and stuff. Okay.
And, yeah, and the nice thing with that too is, like, you know, if you don't want to teach everyone about C and Arduino type programming, you know, if maybe you want to do JavaScript, you can have your environment on your computer that you actually do your coding in, and then have that little bridge, the Fermata, that says, okay, now you've connected this device, and you just want to read the inputs or write the outputs. It wouldn't be standalone. You couldn't like plug a battery in and have it run independently, but it's still, I think, an interesting option that people can kind of play with.
We could also have it show up as a MIDI device, and then you can actually use it with
Right.
synthesizers.
Yeah, like capacitive touch. That would be
Yeah,
great.
so
We'll
maybe
see
like
that.
we're up to
USB
11.
MIDI device,
So
yeah.
MIDI USB native,
Right.
because it was in the original Lufa code. It's actually called Lufa, the USB library firmware. I don't know why it's called Lufa. It stands for something. And we donated to it a long time ago because it's an awesome project. It has like mass storage native, and which is also kind of neat. We could do that as well, though it's a little tougher to think of what it would be good for. It can do mass storage native, and it can do MIDI native, and do keyboard, mouse, all those things native.
The other neat thing too with MIDI, and I haven't played with it much, but I want to try it out. There in HTML5, there's a web MIDI standard now where, in theory, you could have JavaScript just in your browser talking to a MIDI device, and you know,
if it does MIDI native, then it's
right,
MIDI native.
You
yeah.
can have a MIDI firmware on there, because the annoying thing with JavaScript and HTML5, there's no serial access, so you can't access your serial port. You need like a Flash shim, or you need to be using like a Chrome app or something like that. I think they're working on different bridges to that, but it's maybe a interesting way to interact with like a web page with the device. So kind of bridge to different functionality from there.
Okay.
So okay.
So that's number 11. So we're getting there. Is there any
Right.
questions or suggestions?
Yeah, do you want to go through some questions?
Yeah, we're halfway through, so we want to take a small break for a couple quick questions.
Okay.
We'll come up with more later, but we're running out of time
Yeah,
too.
there's a bunch.
Okay.
All right.
Speed round.
I'm going to start from the beginning. And when I tell you the questions, can you repeat it back?
Yes, we will repeat.
Okay, will there be a 3D printed case?
Will there be a 3D printed case? I'm absolutely sure that Noah and Pedro will design a 3D printed case very, very fast. I don't know if we would injection mold the case, but it's something that I have thought of. You know, it would be a clamshell that would fit on top.
Right. It could be kind of challenging though, because you want to be able to access all the ports and things. So
It would be kind of a clamshell with little things, little shell, little cutouts. I have an idea of how it would be, because it's hard to mount it. It would basically clasp it from the outside.
Ah, okay. Interesting.
Next, is it washable?
It's not washable because the buzzer has a port. That's the only item that really, although the buttons aren't like super washable either. So we basically would say, hey, this isn't something that you would
It's not like permanently
attach permanently.
Yeah.
One of the things actually I was thinking of including is a little clip,
Oh,
little
yeah.
like a stick-on. You know what I mean? Like the pin clips that go on the back, or you know, would stick on, and because those are very inexpensive.
Right.
And you would be able to clip it on, and then, you know, even though it's wearable, you know, you would want to use the snap technique where you solder little mini snaps on, or you would just use alligator clips to make your little, temporary wearable, or you'd put it on something like a bag which you would spot wash anyways.
Well, the nice thing too is you don't have, because all the components are on the board, you won't have a lot of wires connected to other components in most cases, you know, if you're not talking other hardware.
Yeah, I mean, it is a wearable board, but I thought, when I think of wearable, I mean, it would just be attached to you while it was doing the amplify, you know, not embedded in your clothing.
Okay. Next up, would you ever consider a color sensor?
Would I consider a color sensor? You know, it is a really cool sensor, and I thought about it. The bill of material cost is just really, really tight, and I need to keep it under a certain price. I mean, if I had a price point of $50, I'd be like, all the sensors. But instead what you can do is you can use the Flora color sensor and then use just alligator clips and clip it on with 4 alligator clips, and that would give you a color sensor, since we do have one as an independent Flora sensor.
Could you do like a little filter, you know, take like some red, green, clear plastic and put that over your color sensor and turn that over a light sensor, and you could maybe detect like basic colors?
You could, but you kind of have to do it all at once.
Right.
So you'd have to have 3 sensors. So.
Right, exactly.
Okay. Next up, have you ever thought about a sound-based board-to-board protocol?
No,
So-
I haven't.
Yeah,
I would
yeah.
usually use something like, you know, for board to board, I wouldn't use sound. I would probably use IR which with this carrier modulation, like 38 kilohertz, wires, which work really well, or RF. It's just sound, because there's just so many noises. It would be very easily disrupted. That's why IR would be better. And I've thought about IR for this, but I'm not sure if I'm going to add it.
Right. Well, an IR could be tough too, like in a classroom setting. If everyone's playing with the board and you're trying to read the one next to you, but you've got all this other light bouncing around,
it can be very challenging and annoying. Yeah.
Okay. Big differences between circuit playground and Flora.
The biggest difference is the integration of all the different sensors, and it doesn't have an on-off switch, which is, instead I have just a generic slide switch. But basically the biggest difference is it is a little bit bigger. I grew it a bit, and the pads have those large holes in them for alligator clips, so you can clip them on, and all the integration of stuff like the 10 LEDs, the 2 buttons, the sensors, the light, temperature, sound sensor, the buzzer, and the accelerometer. So it's a lot more integrated.
Okay. Next, how many capacitive touch buttons are possible?
At this time, 8. There's 8 pins. It goes power, 2 pins, ground, 2 pins, ground again, and then power, 2 pins, ground, 2 pins, power. So it alternates power and ground. And there's 8 pins, 2 on each side, 4 on each side, 2 in each quadrant.
Okay, so this might be a great tool for someone who wants to learn code, not necessarily have to deal with wiring stuff up.
Yeah, this is definitely designed to be for people who want to get straight into the programming experimentation without doing any wiring or soldering. That's kind of what we're hoping for.
Okay. Where's Tony's cat?
Where is your cat?
I almost set up a camera to watch her, but I didn't do it this time because the problem is, like, she'll sleep under the bed, so you never have the camera in the right spot. So yeah.
Okay.
But she's happy. She's safe.
Okay, she's safe.
Yep, she's home.
She's safe in the underground bunker.
Yep.
Someone has suggested use 2 buttons, increase, decrease volume, and store it in EEPROM.
Yep, we could do that. We could definitely use. It's nice that it has a little bit of EEPROM. There's also flash if you really want to do stuff like you could store little sound clips in it.
Right.
If you wanted to, like we did with the. I'm actually reminded of because somebody did an ornament with the Mario coin sound. 30 you have 30 kilobytes of flash after the bootloader, 20 kilobytes of flash, which is like nothing in terms of audio video storage. But if you don't mind like super low sampling,
right.
You can kind of sort of
8-bit, 4,000 kilohertz.
4 kilohertz. You can do like a sound effect,
right.
Which is recorded. There's also the Talkie library, so we could do a little
speech generation.
Speech generation. So I don't know if it would work really well, but the Talkie library is available, so I'm going to write that down.
And yeah, that would be a fun project. You can make like a speak and spell kind of thing, because the Talkie is modeled after that old kind of 70s TI speech synthesis chip.
Yeah,
so
I don't know actually whether the Talkie library, I don't know if it takes text. I think it takes phonemes.
Right, well, and you kind of define, you have like a little library where you say, these are the words I can speak. And so if you have like numbers or like letters, you could do something like that potentially.
Well, you could also just type into the serial console like letters and it would say like
spell something out.
HELLO, like you would speak it out. It would basically
right.
just be a speak and spell. So Talkie library, and I'll just put down speak and spell. Which is actually a good programming project because you have to go through each character and speak it out.
Yep.
Okay.
All right.
Do people have any other suggestions for projects? I'll take suggestions from the peanut gallery.
Yeah. Are there any soldering spots on the back?
There are not. The back is going to be completely blank. I mean, there'll be silk screen on it with instructions and maybe some specs, but it's designed to be completely flat on the bottom. All of the pins are taken. So any pins that are not brought out here, these 8 on the outside, they're all taken. In fact, I even started taking pins that are not normally accessible from Arduino, like the TX and RX LED pins, which are used for, there's another 2 things that are missing. I took those out because I just figured we have so many LEDs instead. And those pins are used for alternative stuff. Like one of them controls the capacitive touch transmission pin, because I actually just ran out of pins.
Mm-hmm. We've got all the sensors on there.
Because there's so many sensors, switches, buttons. SPI is used for the accelerometer, so it's like 4 pins right there.
Okay. Request for a Simon game.
Simon, it's on there. It's a
okay.
number. 6. Number 6.
And you could even do a variation of Simon where it's like not necessarily touching things, maybe like moving it. So they have the accelerometer, like, you know, tilt it left, right, up, down.
Yeah,
like
tilt
that.
it. I'll put that down under Simon.
Yeah.
Maybe
There's a
tilt.
project idea that someone wants to contribute to this brainstorming session.
Okay.
And a simple activity monitor, the more you make the accelerometer move, the more pixels fill up.
Ah,
Okay.
that was a funny iPhone app that I think they took out of the App Store, whereas you're supposed to throw your
Oh,
phone
yeah.
in the air
remember
and it
that.
would record how high you threw the phone. And, you know, it was a game, like, who could throw their phone higher?
that was like the greatest troll app. I remember reading and be like, that's a bad idea.
Well, you could actually do that here and not worry because it's, you know, a little $25 board or something where, you know, it's not as bad when it hits the ground.
One thing you could do is, I mean, it's a little ridiculous, but you could do it as you you put it in a padded box type thing, and so because it's basically the batteries that you don't want to like fly everywhere, and you basically tape the battery pack closed, and you could drop it, and it would actually measure gravity.
Yeah, yeah. Oh, yeah.
You know
so
what I mean? You
false.
could actually do a gravity. I mean, the thing is, I'm a little scared of suggesting that as a project because I just know people will be like, I just dropped it from my roof, and like it just everything went all over the place.
Well, it could be like the data log. You could do a variation of the classic put an egg in a box and drop it, you know,
Yeah.
physics kind of little experiment to see, okay, maybe.
I'll write it down. Physics drop test.
Yeah, right. Throw it in
Yeah.
the box and
Yeah.
use that instead of an egg.
Okay. Did your flora survive? But it can do, it can do very high speed physics measurements. So there is stuff you can do with measuring physics and stuff. Well, maybe we'll think of some ideas for
Right.
some physics projects.
And you've got analog inputs also, so you can
There's analog
connect them
inputs.
up to things. Like one interesting demo that we thought of was build a resistor. Just take graphite, take a lead pencil, and just draw a line with
Oh
it.
yeah, that's right. Graphite resistor.
Exactly, and then put alligator clips, and as you move the clip along the line, it's going to change the resistance value. So it's a really good way to teach about resistors and you know, what it actually means. You can see this physical thing. Like, here's this line.
Resistor slash, it's actually potentiometer.
Yeah, exactly right. Yeah,
Yeah.
physical kind of potentiometer. Because that was one thing I think that you thought about putting on the board was, you know, potentiometer you could drop on and twist, but the tough thing is finding one that, you know, is
It's a
cheap
very
enough
hard
and-
one to get
Yeah.
one that fits, so I skipped. It's the one thing we didn't put in was a potentiometer. Okay, well I think we got 14, and I think we've only scratched the surface, as it were, for projects. So we'll kind of come up with more stuff between now and later on. We'll do Ask an Engineer. But thank you so much for hanging out and coming up with ideas. And people, you know, we're gonna send in ideas if you've got ideas. Post them up, and also when we release it, I'm sure we'll see a lot of ideas as well.
And the cool thing too, I think, is that you can actually follow the whole process of this board, like design through this first revision, just through the Desk of Ladyada videos you've done. So there'll be kind of a whole history of like where did this come from and like how was
Yeah,
it
you
made,
can
how did
see
it
we
design?
have like a 5 or 6. I mean, like a lot of them are just seeing me make not mistakes, but design decisions
The
that
process
didn't work
of
out.
that.
You know, like there's things that I did that I'm like, you know what, I decided not to do that. You know, I thought about maybe adding IR sensing and transmission, and in the end, I thought, no, you know what, I'm gonna skip it for this initial
Right.
release and see how it goes, because getting everything to the price I want is a little bit of a challenge, but I really want to make sure I hit that price to get it to people, because again, if it's $50 or $100, it's real easy to
Right.
add everything in,
difficult balance of like.
but to make it manufacturable and sellable in a way that is maintainable is a little tougher. But I think this is kind of fun. So we'll think of some other more projects. I think this is a good brainstorming session.
Cool, yeah.
Brains were stormed.
Excellent.
All right.
Okay.
Okay. Thank you, everybody, and we'll
Cool.
see you
Excellent.
later on.
3 and then 8 till then.
2 engineers. We'll see you.
Yeah, so show and tell 7:30.
Show and tell, 7:30 p.m. Eastern Time as usual, and then right afterwards we go straight into Ask the Engineers. 2 engineers, me and Tony.
Okay.
Later. you.